Hello everyone. Today we will discuss about configuring the database into archiving mode and the user managed backups. Let's see the objectives. Configuring database archiving mode. Describe the difference between ARCHIVELOG and no ARCHIVELOG modes. How to configure a database from no ARCHIVELOG mode to ARCHIVELOG mode. How to manually perform the archiving of logs. How to configure multiple archive process, and how to configure multiple destination for the archiving process. And user managed backup. It describes what are the user managed backups and recovery operations, how to perform closed and open database backups, how to backup the control file, how to clean up after a failed online backup, and how to detect corruptions in the backup files. First, let's see configuring database archiving mode. Archive redo logs. Now all transactions are recorded in the online redo log files. This allows for automatic recovery of transactions in the event of database failure. If the database is configured for no archiving mode, no redo history is saved to archived log files, and recovery operations are limited, and a loss of transaction work may occur. This is the result of automatic recycling of log files, where older log files needed for recovery are overwritten and only the most recent part of the transaction history is available. We can configure a database in ARCHIVELOG mode so that a history of redo information is maintained in archived files. The archived redo log files can be used for media recovery. The database can be initially created in ARCHIVELOG mode, but it is configured for no ARCHIVELOG mode by default. No ARCHIVELOG mode. By default, a database is created in no ARCHIVELOG mode. The characteristics of operating a database in no ARCHIVELOG mode are as follows. Redo log files are used in the circular fashion. A redo log file can be reused immediately after a checkpoint has taken place. After redo logs are overwritten, media recovery is only possible to the last full backup. Some implication of this mode. If a tablespace becomes unavailable because of a failure, we cannot continue to operate the database until the tablespace has been dropped or the entire database has been restored from the backup. We can perform operating system backups of the database only when the database is shut down. It must have been shut down with the normal or immediate option. We must backup the entire set of data files and control files during each backup. Although we can backup the online redo log files, it is not necessary. The files in the type of backup are all consistent and do not need recovery, so the online logs are not needed. If the online redo log files have been overwritten, we will lose all data since the last full backup. ARCHIVELOG mode. A filled redo log file cannot be reused until a checkpoint has taken place and the redo log file has been backed up by the archiver background process. An entry in the control file records the log sequence number of the archived log file. The most recent changes to the database are available at any time for instance recovery, and the archived redo log files can be used for media recovery. Archiving requirements. The database must be in ARCHIVELOG mode. Issuing the command to put the database into ARCHIVELOG mode updates the control file. The archiver background process can be enabled to implement automatic archiving. Sufficient resources should be available to hold generated archived redo log files. Implication of setting the database in ARCHIVELOG mode. The database is protected from loss of data when media failure occurs. We can backup the database while it is online. When a tablespace other than system goes offline as a result of media failure, the remainder of the database remains available because tablespace can be recovered while the database is open. Some media recovery option with ARCHIVELOG mode. We can restore a backup copy of the damaged file and use ARCHIVELOG files to bring the data files up to date while the database is online or offline. We can recover the database to a specific point in time. we can recover the database to the end of a specified archive log files, and we can recover the database to specific system change number. The initial archiving mode is set in the create database statement. The default is no archive log mode, which eliminates the archiving of redo information generated during the creation of the database. We change the archive log mode by using the alter database command while the database is in the mount stage. Alter database archive log. After the mode has been changed from no archive log mode to archive log, we must backup all the data files and control files. Our previous backup is not usable anymore because it was taken while the database is in no archive log mode. The new backup that is taken after putting the database into archive log mode is the backup against which all our future archive log files will apply. Automatic and manual archiving. After a database is set in archive log mode, we must decide whether online redo log files are to be archived automatically or manually. This is second step in creating archive redo log files to use for recovery. Automatic versus manual archiving. In automatic archiving, the archiver background processes are enabled and they copy redo log file as they are filled. In manual archiving, we must use SQL Star Plus or Oracle Enterprise Manager to copy the redo log files. It is recommended that we enable automatic archiving of log files. Some guidelines. Before deciding on the archive mode, we must set the database in archive log mode. Failure to switch to archive log mode will prevent archiver from copying redo log files. The database should be shut down clean before enabling the archiving process. If the archiver processes fail for any reason after transaction activity has filled up all the redo logs, the Oracle server hangs. This is legitimate hang because setting the database in archive log mode tells the Oracle server not to overwrite the online redo logs unless it is archived. Thus, archiving online redo logs must keep pace with the transaction activity on the system. Parallel data definition languages like DDL and parallel data manipulation languages DML operations may generate a large number of redo log files. A single archiver process to achieve these redo log files might not be able to keep up. Oracle starts additional process as needed. However, if we wish to avoid the runtime overhead of invoking the additional processes, we can specify the number of processes to be started at instance startup. We can specify up to 10 archiver processes by using the log archive max process parameter in 10G and up to 31 archiver processes in 11G. When log archive start is set to true, an Oracle instance startup with as many archiver processes as defined by log archive max processes. We can always spawn additional archive processes up to the limit set by log archive max process or kill archive process at any time during the instance life. How to start or stop additional archive processes. Dynamic number of archiver processes. During a period of heavy transaction load or activity, we can temporarily set additional archive processes to eliminate archiving bottleneck. After the transaction activity returns to a normal level, we can stop some of the archiver processes. For example, every day of the month, we start the instance with 2 archiver processes. During the last day of each month, the activity always increases. So we can start additional processes by a simple command, alter system, set log archive max processes is equal to 3. The day after, if the instance is not shut down, we can issue the following SQL command to stop the additional archive process. Alter system, set log archive max process is equal to 2. Note that if the instance is shut down at night, the next day it would start again with only 2 archive process as specified in the initialization parameter file. Enabling automatic archiving at instance startup. If the database is in archive log mode, then archiver processes can be started every time the database instance is started by setting the parameter log archive start is equal to either true or false. If it's true, then automatically starts n number of archival processes upon instance startup, where n is determined by the value of log archive max process. False inhibits archiver from starting upon instance startup. After the initialization parameter is set, the archiver process automatically start upon instance startup, eliminating the need for us to start automating archiving manually. We can enable automatic archiving without shutting down the instance by using the alter system command. The database should be in ARCHIVELOG mode. Open the database, then give this command archive log list, then enables the archiver process. On Unix, the command to enable automatic archiving is alter system archive log start and then to the Unix directory address where we want to place our archive logs. The archiver process automatically archives log files as they are filled. We can optionally specify the archiving destination with the two options on the alter system archive log start command. If the archiver processes are not initiated through the initialization parameter file, then we must restart the archiver processes each time we restart the instance. We can always stop archive processes regardless of how we started them by using the alter system command in /+ prompt. First, execute the command to stop the archiver processes if archiver processes have been already enabled. Second, we can do this thing or stop the archive processes by giving a command alter system archive log stop. A second step ensures that automatic archiving is not enabled upon instance startup by editing the P file and setting the parameter log archive start is equal to false. Stopping archiver processes does not set the database in no archive log mode. When all groups of redo logs are used and not archived, database will hang if it is in archive log mode. If our database is in archive log mode and we have not enabled automatic archiving, we must manually archive online redo log files. Steps explanation. First step, execute the alter system command, alter system archive log. Then here we can either give the sequence or the current. The server process for the user executing the command performs the archiving of the online redo log file. In addition, we can use manual archiving when automatic archiving is enabled to re-archive an inactive group to another destination. We must connect with administrator privilege to issue the alter system archive log command. Log archive dest _ n parameter. This parameter defines up to 10 archive log destinations. This parameter is valid only if we have installed Oracle Enterprise Edition. Log archive dest and log archive duplex dest parameters these are alternative means of defining multiple archive locations and is to specify a primary location by using the log archive dest parameter and to use the log archive duplex dest parameter to define a backup destination. Note, the two methods for defining archive destinations are mutually exclusive. For Oracle Enterprise Edition users, the log archive dest parameter has been deprecated in favor of the log archive dest _ n parameters. If Oracle Enterprise Edition is not installed or is installed but you have not specified any log archive dest _ n parameter, then this parameter is valid. Log archive format parameter is used to include the log sequence number and the thread number as a part of the file name. Additional option with log archive -n. There are two types of options with this parameter, mandatory and optional. When using the log archive -n parameter, a destination can be designated as either mandatory or optional. Mandatory implies that archiving to this destination must complete successfully before an online redo log file can be overwritten. Optional implies that an online redo log file can be reused even if it has not been successfully archived to this destination. The optional mode is default mode. Then the reopen attribute. The reopen attribute defines whether archiving to a destination must be re-attempted in case of failure. If a number is specified along with the keyword reopen as reopen is equal to 600, the archiver attempts to write this destination after the specified number of seconds following a failure. The default is 300 seconds. If reopen is not specified, errors at optional destinations are recorded and ignored. No further redo logs will be sent to these destinations. Errors at mandatory destination will prevent reuse of the online redo log until the archiving is successful. Specifying the minimum number of successful archive locations. The number of destinations that need to be archived successfully before an online redo log file can be used is determined based on the following settings. The number of destinations defined as mandatory and the value of log archive min succeed dest parameter. The value specify a lower bound on the number of local destinations that need to be archived. If this number is less than number of mandatory local destinations, it has no effect on the archiving behavior. If this number exceeds the number of mandatory local destinations, the number of local destinations archived must be at least equal to this value before an online redo log file can be reused. Log archive dest and parameter. The state of archive destination can be changed dynamically. By default, an archive destination is in the enable state, indicating that the Oracle server can use this destination. The state of an archive destination can be modified by setting the corresponding log archive dest state underscore n parameter. For example, to stop archiving to a mandatory location temporarily when an error has occurred, the state of that destination can be set to defer. A destination may be defined but is set to defer in the parameter file. This destination can then be enabled when another destination has an error or need maintenance. Log archive format is equal to extension, where extension should include the variable small %s or capital %s for log sequence number. The default value is operating system specific. For example, on Unix machine, log archive format is equal to ARCH %s dot ARC. If we use %t, either capital or small, it includes the thread number as a part of file name. If we include capital %s, then it causes the value to be of fixed length padded to the left with zeros. We can view information about the archived log files by using the following view. $archive log. It displays the archived log information from the control file. $archive underscore dest. For the current instance, it describes all archive log destinations, the current value, mode and status. $log history contains log file information from the control file. $database, current state of archiving. $archive processes provides information about the state of the various architecture process for the instance. Next is user managed backups. Backup terminologies. Whole database backup. Whole database backup refers to a backup of all data files and the control file of the database. Whole backup can be performed when the database is closed or open. This is the most common method of backup. The whole backup that is taken when the database is closed after the database is shut down using the normal, immediate or transactional option is called a consistent backup. In such a backup, all the data file headers are consistent with the control file, and when restored completely, the database can be opened without any recovery. When the database is operated in no archive log mode, only a consistent whole database backup is valid for restore and recovery. When the database is open and operational, the data file headers are not consistent with the control file unless the database is open in a read-only mode. When the database is shut down with abort option, this inconsistency persists. Backup of the database in such a state are termed as an inconsistent backups. Inconsistent backups need recovery to bring the database into a consistent state. When database need to be available 7 days a week, 24 hours a day, we have no option but to use an inconsistent backup. Then this can be performed only on databases running in archive log mode. Tablespace backup. A tablespace backup is a backup of the data files that make up a tablespace. The tablespace backups are valid only if the database is in archive log mode, because redo entries will be required to make the data file consistent with the rest of the database. We can make tablespace backups when the tablespace is read-only or in offline normal mode in no archive log mode. Data file backups. We can make backups of a single data file if our database is in archive log mode. We can make backups of read-only or offline normal data files in no archive log mode. Control file backups. We can configure ARCn for automatic backups of the control file after a backup or a copy command is issued. The control file can also be backed up through SQL commands. User managed backup and recovery does not use recovery manager. Operating system commands are used to make backups of the database files and to restore them in recovery situations. The recovery commands are issued in SQL* sessions. Before we begin the backup, we should obtain information about the files of the database by querying the $data file, $control file, $log file, and $tablespace views. Backup methods. These are various methods of taking backup. 3 kinds of backup: logical done using export and import utilities and data pumps. Physical backup is taken by operating system commands. ARCn backup using catalog and no catalog mode. We will discuss physical method in this session. A consistent whole database backup, also known as closed database backup, is a backup that is taken of all the data files and control files that constitutes an Oracle database while the database is closed. It can also include the online log files, parameter files, and the password files. When using user-managed backup operations, we should define an operating system backup procedure that will always back up the Oracle data files, control file, parameter files, and the password file as a part of a strategy to safeguard against the potential media failure that can damage these files. Ensures that the complete path name of the files are noted and used appropriately in the backup. In a multiple database environment, care must be taken to associate these files with the corresponding database through a naming conventions. Because the names of a parameter file and password files are not recorded in the dictionary. Advantage of making consistent whole database backup. A consistent whole database backup is conceptually simple because all we need to do is shut down the database, copy all the required backup files to the backup locations, open the database. A minimal number of commands is required to perform a closed database backup. We can automate the closed database backup process by executing a simple script that will require minimal operator interaction and does the following: shuts down the database, copy the control file and data files, open the database. All files copied during a closed database backup are consistent to a point in time. No transaction occurs while the backup is taking place because the database is unavailable for use. Some disadvantages. For business operation where the database must be continuously available, a consistent whole database backup is unacceptable because the database is shut down and unavailable during the backup. The amount of time the database is unavailable is affected by the size of the database, the number of data files and the speed with which the copy operations on the data file can be performed. If this amount of time exceeds the allowable downtime, we must choose another type of backup. The recovery point is only to the last full consistent whole database backup, and lost transactions may have to be entered manually following the recovery operations. Perform a consistent whole database backup while the Oracle server instance is shut down. First, compile an up-to-date listing of all relevant files to backup. Second, shut down the Oracle instance. Third, backup all data files and control files by using an operating system backup utility. We can also include the redo log files although it is not required. Fourth, restart the Oracle instance. Some guidelines. The default option for the shutdown command is normal. Use transaction or immediate if there is any chance that transaction or processes are still accessing the database. Consider a reliable automated procedure for this operation to ensure that every file is correctly backed up. Backup the parameter file and the password file when performing full closed backup. We do not need to include the file associated with read-only table spaces in full backup. If the database is opened while the offline or cold backup is performed, the backup is invalid and cannot be guaranteed usable in recovery situation. If business requirements do not permit us to shut down the database to perform backups, then we can use the following method to perform backups of the database while it is in use. Perform backups of all the table spaces or individual data files while they are online or offline. Backup the control file to a binary file or create a script to recreate a control file. The online redo log files do not need to be backed up. Advantage of making an open database backup. The database is available for normal use during the backup. A backup can be done at a tablespace or a data file level. Supports business that operate all day, every day. Consideration when making an open database backup. More training is required for the DBA. Tested and automated scripts are recommended for performing open database backup. We can perform backups of the tablespace or individual data files while the database is in use, provided two criteria are met. First, the database is set in the ARCHIVELOG mode. Second, that the online redo logs are archived, either enabling the automatic archiving processes or manually archiving the redo log files. The Oracle server enables us to backup all data files for a specific tablespace or an individual data file or for a tablespace. Regardless of the option we choose, the database remains available for the normal use during the backup process. When a data file is placed in backup mode, more redo log entries may be generated because the log writer writes block images of changed block of the data file in backup mode to the redo log instead of just the raw information. This could have significant impact on the size of redo logs and the performance of log writer. How to perform an online tablespace backup. Set the data file or tablespace in backup mode by issuing the alter tablespace begin backup command. This prevents the sequence number in the data file header from changing, so that logs are applied in recovery from backup start time. Even if the data file is in backup mode, it is available for normal transactions. SQL alter tablespace users begin backup. Use an operating system backup utility to copy all the data files in the tablespace to the backup storage. The log sequence numbers in the backup file may be different when each tablespace is backed up sequentially. Then after the copy command, we have to and the backup on the tablespace by issuing a command alter tablespace users and backup. Backup of online data files. Taking backup of an individual data file is same as taking backup of the tablespace. Instead of tablespace clause, we have to use datafile clause and replace tablespace name with the datafile location. Now the steps. First, change the status of tablespace from read-write to the read-only by using alter tablespace SQL command. Alter tablespace, then tablespace name, read-only. When the alter tablespace command is issued, a checkpoint is performed for all data files associated with the tablespace. The file headers are then frozen with the current ARCn number. When we make a tablespace read-only, we must backup all of the data files for the tablespace. The DB writer process writes only to the data file whose tablespaces are in read-write mode and normal checkpoint occurs on these files. Because no writes are performed on data files for a read-only tablespace, the only time the file must be recovered is when they are damaged. Changing the status of tablespace from read-only to read-write results in database writer writing to the tablespace files and checkpoint occur as they usually would. From this point, we must resume a normal backup schedule for all the data files associated with the tablespace. Alter tablespace command to change a tablespace to read-only updates the control file. When performing a recovery operation, the control file must correctly identify read-only tablespaces, otherwise we must recover the tablespace. Tablespaces, table, indexes or partitions may be set to no-logging mode for faster load of data when using direct load operation. When the no-logging option is set for a direct load operation, insert statements are not logged in the redo log files. Because the redo logs do not contain the value that were inserted when the table was in no-logging mode, the data file pertaining to the table or partition should be backed up immediately upon completion of the direct load operation. If we are not using ARCn for backups, we must manually backup the control file. We must protect against loss of the control file because information in the control file is required at instance startup. Certain status information in the control file such as current on and redo log file and name of the database files is used by the Oracle server during instance or media recovery. We need to maintain a recent copy of the control file after every change to the database configuration. Some guidelines. Multiplex the control file and name them in the parameter file using the parameter control_file. The alter database backup control file to trace command creates a script to recreate the control file. The file is located in the directory specified by the initialization parameter user dump dash. This script does not contain ARCn metadata. In addition, the individual control file should also be backed up by using the alter database backup control file to the file name command. This provides a binary copy of the control file at that time. During a full backup, shuts down the instance normally and use an operating system backup utility to copy the control file to backup storage. We can use the create p file statement to create a backup of the SP file. The content of the SP files are exported to an initialization parameter file in text format. The create p file command can create the file in a default location, or we can specify the file name as shown in the second example of this slide. The DBVERIFY utility enables us to perform verification of data files by checking the structural integrity of data blocks within specified data files. The utility is external to the database in order to minimize the impact on database activities. Steps explanation. The utility can be used to verify online data files. We can invoke the utility on a portion of data file. The utility can be used to verify offline data files. We can direct the output of the utility to an error log. Now running the DBVERIFY. The name of the executable for the DBVERIFY utility varies across operating system. It is located in the bin directory under the Oracle home directory in the Unix environment. We invoke the DBVERIFY utility using a command line interface. We use this utility primarily to ensure that a backup database is valid before it is restored, or as a diagnostic aid when we have encountered data corruption problems. So this is all about archiving mode and the user backups. Thank you.